Hello everyone, greetings. This is Neri Chem. We are on question 6 of the HSC 2018 paper. Sodium hydrogen carbonate is often used to clean up large spills of acids and alkalis. Dangerous. Why is it a suitable chemical for this application? First of all, you know what sodium hydrogen carbonate is because you, I can tell, have already baked cakes in your life. Now, the chemical formula is NaHCO3. I will draw you the shape of the molecule. The anion looks like this. We have a carbon in the center and a carbonyl bond, and then we have two oxygens. One of them will have the hydroxyl group, which is the only proton in the molecule, and the other one will not have the proton, so it will have the negative charge. And as you can see, it's triangular in shape. The sodium would be the positive counter-ion. There's a single negative charge. Now, I want you to look at question or answer A. It is diprotic. Let's not read the rest of the sentence because diprotic is already problematic. If you look at the molecular formula, diprotic would mean that it has two protons, but there's only one single H, so it cannot be A. It is amphiprotic, stable and easily handled. Well, this sounds more correct. What does amphiprotic mean? Amphiprotic means that it can either receive or donate a proton. How could this molecule receive a proton? Well, very simple. Simply, it would bond with the negative charge on the oxygen. And if it were to lose a proton, well, simply this hydroxyl group, which I've highlighted, could lose a proton. So it can either receive or lose a proton, meaning it is amphiprotic. Is sodium bicarbonate stable? Well, I would say have a look at your kitchen cupboard where you keep your flour and your sugar. Look at the expiry date on your small tub of sodium bicarbonate. You might ask yourself, why do I use sodium bicarbonate when I'm baking cakes? Well, very simple. It's a leavening agent. What is a leavening agent? When sodium bicarbonate combines with an acid, it will decompose to produce carbon dioxide gas, and this carbon dioxide gas will swell your cake and make it rise because these bubbles are increasing the volume of your cake. So let's look at C just for the educational purposes. It cannot be C because we already see the word diprotic. We've already established that sodium bicarbonate is not diprotic. Carbonic acid, however, which I will draw on screen, H2CO3. Now, this would be diprotic. We know it's diprotic because there are two protons, but this is not the molecule we're talking about. We're talking about sodium bicarbonate. So it cannot be C. Now, D is true in the fact that it's amphiprotic, so that's correct, and only small quantities are required. Okay, well, let's have a think about that. We're talking about large spills of acids. So when you add sodium bicarbonate to an acid, you will get the following reaction. Let's pretend that the acid spill was a truck which was containing large amounts of hydrochloric acid, which was going through the motorway and then crashed, fell all over the motorway. HCl plus NaHCO3. Now, your biggest temptation right now is to simply do NaCl plus H2CO3. Now, that's an error. The thing about H2CO3, which is carbonic acid, is that in the presence of water, it will rapidly degrade. What will it degrade to? Water and carbon dioxide. Now, this is the reaction I was talking about, which happens in your cakes, and that's why you get a cake. It's a leavening agent. We have already established that Correct answer is B. And easily handled was the last part of question B, which I would just very like to quickly mention. Easily handled to me screams toxicology, which means that it is basically benign to you as a human being. And you know that sodium bicarbonate is benign because you eat it. So thank you very much. I hope you have found this useful, and I will see you in the next one. Goodbye.